Hello, my name is Marco Esser. Here's my non-examined assessment for Computer Science A-Level, and here's a walkthrough of my code of a disease simulation. Here we have the main public class over here, um, which has all its various public and private attributes. Here mainly has the grid and the people, which is a new list, and the grid dimension over here, which is used by taking this value from which is the grid dimensions -1 to make sure it's the right size, so it's not too large. Here, the main sub or private sub grid, which loads the actual grid initially before starting the simulation. We have the set size for each cell, scale, and each cell is a sim cell, which is a later class you'll see. Here, this creates a list of the population from 0 to a certain number, but here for default we have 500. This adds the new person to the people's list and gives them a random coordinate, which here in Monty, which is a random new random math function, which picks a number between 0 and 40, and this will give them the grid position. Next, we have the bit that draws a grid. It goes through each row and column, and for each row and column, a new cell is made, which is as a new sim cell. Here is all the dimensions and size and scaling for each cell on the grid. Then over here, this is put onto the for each row and column, it's put onto the grid to say that the cell was made, which is used for later when looping through the whole grid. And here for the sim grid as well, which is called as a new sim cell. Then to ensure it's empty, this over here uses the empty function, which makes sure that it is not occupied and it is free. Then after all this is done, it adds the cell into the main form, which is over here. So this is my main form which I'm using. The grid will be drawn over here, and here's all my buttons and stuff. Then next we have loops through each person in the people's list. If the so for each person in people's list, it will say that the sim grid, which is used in the backend for later movement, is true. Then it goes on, and these over here, these get x and get y, return the function of x and y, return the location of x and y of the person that is looping in. If the person is infected, then the grid position that is drawn initially gets these coordinates and turns it red, and the infected is it is true and it is updated. Same here, but it's healthy, and calls this method instead, and the healthy bit's updated. Then next we have the sim cell, which is the next public class, inherited picture box property for the drawing. Here we have the three properties: occupied, infected, dead. This initializes it over here. Here we have the infected method, healthy, empty, and dead. This one returns true, false if it's healthy, and here's the used later when changing the color for red for if it's infected, and green if it's healthy, and empty is white, and it occupied is false because no one's there, and dead it's true for the first loop, you'll see later, but it's false later on, but this is initially, and here the color is black. Then for the class person, which is the list, each person has a location on a grid. They have whether they're infected, the probability of their dying, whether they're dead or not, and infection, and the three random for probability of infection, death, and initial infection. Then over here, when the list is made up here, these coordinates are passed through, which is so when each new person is created, this is passed through here, and the location x and y is given, and then here we have the random num, which is declared, and the random number is generated by using the random for initial infection new random number or math function, and then here it chooses a number between 0 and 1000, divides it by 1000 to give a nice decimal number, and then here the if statement checks if the random number is less than the probability of infection, which is up here, then the person is infected true to simulate a real life situation. Here we have different functions, returns location X and Y of the person, whether they're infected, whether they're dead. This is used later in updating a new location when moving. And here we have infection probability check, which is used for when a person is going to be infected. So here, probability of infection, here's a random number, it's generated between 0 and 1000, exactly same as above, to give a nice decimal number to compare to 0.1. If it is less than the probability of infection up here, then it's infected, if not false, and then return whether infected or not. Then we have the dead probability check, which is exactly the same, but just returns whether whether dead or not. Then we have the method which says they are not infected anymore, which is when they become healthy, and when they're infected for the boolean. Then over here we have the start simulation. This is when this button over here is clicked. Once this is clicked, then it goes through this loop where if the sim is started, if the sim is not started, yes, then it goes to the main simulation loop. If it is paused, then this will be used later for when pausing. And then here, this is the function, the button stop. So this button over here, stop. Once that's clicked, then if the sim starts true, then it goes to the stop simulation. And the stop simulation over here is whether it says here pause sim is true. It says that it's true, that it's paused. Then in here it does the pausing, where the threading was imported earlier on, and uses that to pause simulation. Then once that's finished, the simulation is continued. Then for the main simulation subroutine, where all the movement is going to take place, here the sim start is true, the time interval is declared, and this is for milliseconds, so 1 second for each interval. Then the timer starts. Statistics are updated to show how much population, how many infected, healthy people we have on the grid. Then once the loop starts, the day counter is increased by 1, and then in this loop, for each person in people's list, here we have the random things. This bit over here checks if there's a free space over here. If this is free space, then it does this loop over here, which gets the correct coordinate. So here is a randomly generated coordinate for x and y in any given direction in 8 directions. So north, northeast, east, southeast, south, southwest, west, and northwest. Then if the new coordinate in the new sim grid, which is used to compare for a spare place, is false, which means there's a space, then the next new random x chord and y chord is the new random x chord and y chord generated up here. And the vacant location is true, so it exits the loop and continues to the next bit. In this bit over here, if the person's infected, then it calls this bit over here to check if they're going to die or not. If they do die, then the old grid location is going to be empty, and the new grid location is going to be dead, which is black. And here they are not infected anymore, so that returns that the infected is false, and the new location is initialized for the person, so that they can be used for future movements to check. Then the death count is incremented and the infected count is decremented. Then for the next bit over here, if the person doesn't die, then it checks if it does a division here for remainder to check for every 7 days, which is when a person recovers from influenza. If the mod is 0, which means it's a whole number, so 7, 14, 21, 28, then the remainder should be 0. And then here it then says that the person